Alright, so 2 minutes later, I actually figured out what the problem was. So we got this thing that's called pointers, and they're all by reference. If you notice, my old code, I was taking the pointers from command, making command pointers, and I was passing them. But remember, pointers are by reference. So if pointers are by reference, when you erase that pointer, it erases everything out of the stack. That's one thing to be careful about. I'm glad this kind of happened because I kind of fudged up on my number one rule, and that's not being too generous with pointers. And if you notice in my last video, it bogged down like my everything. I'm very harsh on my computers. And if you notice, it bogged down everything. When I was doing the compile, that's why I did that simple compile. And also it bogged down when it was actually running, because there are some remnants that are still running, especially if you're not freeing your your actual memory. So a good thing to do is, if you're going to make a pointer out here, so see how I passed this by reference, it's best to whatever memory you're using at the end, you want to actually free that memory. Because you can't depend on garbage collection all the time. C, it can be very memory intensive. So for instance, if I was to do this right here, I might want to just do a free right here. And since I'm passing this by reference, once the whole program is done, I want to free that. But because this is not a pointer at this point, I don't need to free it at all. It'll automatically do the garbage collection. That's why you see that syntax error right there. But if I was to actually do something like this, then see what happens. It keeps that pointer forever. So be careful with those pointers. Go by reference. Whenever you want to change something, what I mean by reference is you make the local copy, and then you just pass that by reference through, which right here you can do it kind of like this. And then what happens is, if you notice in the signatures, I put those as pointers. Okay, so most of this garbage is going to have to change. Maybe not the copy command, but most of this stuff is going to have to change. At least in the copy command, you pass a pointer in here, but you don't pass a pointer here, because you want this to disappear. You want that source to stay as is, and you don't want that source to change. So that's just a lesson learned. I actually got the whole thing running too, so if I was to clear my screen, and if I was to add sub, and let's give it a run, see? We get all of our results here. See how we did all our results here? Okay, we got our subtraction we did first, our add we did again, then our subtraction again, and then that's a complete CLI right there. The most important part here is the stack that you use to trace in order, to do things in order. You can also, if you want to make it where it's like not memory intensive, you will actually use a real stack where you do a pop and a push and all that stuff. But that's going to take a lot of code to do, but it'll make it more efficient, because once the command is done, you want to get rid of it, and you want to just pop the next top of the stack that's in queue. But this is just a poor man's stack, I would say. We call it a poor man's stack because you have to do a lot of maintenance on that stack if you keep it this way. But if you make a real stack, then you'll do the maintenance later, and your code will automatically do the maintenance. So like I said, some of the fixes that I did, and I can change this back. I just want to show you some of the code, what the actual code is doing. And so I changed some things, like in this router right here. I don't pass that by a pointer anymore. So all the commands that I'm using temporarily, I don't pass it as a pointer. I make sure that the instruction stack is actually the true copy of it. So that's what I like 5 minutes after the last video, that's what I discovered, and I hate when that happens. So now we have a fully functional CLI. We have a skeleton for it. If you were to use my CLI and want to do other things, you might have to change your commands, possibly. Obviously, this is a calculator CLI kind of thing. You would have to change whatever's in your commands, but this right here, this iStack can stay. And then what you have to do is actually make the logic for the switch, which I usually like to use linked lists for my stacks, or use a linked list for the instructions that are about to run, because sometimes I want to make weights just in case I want to make a real calculator. But most CLIs, you would have like a chain effect. So all of the so imagine you have a linked list or an AVL tree, and you want a chain effect, and you do a breadth first or a depth first to make that chain effect. Because if you notice, the computer reads everything backwards. Okay, so first it takes the value, and you're saying, I want you to store it in here. And if you notice, in grade school, they teach you this way. This is algebra. Okay, we don't say 0 is equal to index. We say index is equal to 0, which is going backwards, where you're storing this going this way. So the instructions are all read backwards. This is the same as SQL compilers and other compilers and stuff like that, where when you're doing storage and stuff like that, making variables, everything is read backwards. Peace.